Okay, good morning all the students. In the last class, we were left with some topics that were not covered in the 6th lecture. We'll try to complete that today, and from Monday onwards, we'll continue with the later lectures. Okay, so in the last class, in the last 2 classes, we have seen, let me start the slideshow 1 second. Yeah, in the last 2 classes, we have seen how to read the data from a Hadoop URL, how to read the data using the file system API by passing the path as parameter, and how FS data input stream can be used to perform these 2 tasks, and how to write the data to a Hadoop file system by using FS data output stream, and how to create directories successfully by using mkdirs method. And in yesterday's class, we have seen how to work with file status class. If you want to know the metadata about a file in the file system on Hadoop, you can retrieve that metadata by using file status parameters. File status has various parameters like what is the block size, who is the authorized user, what are the file permissions that are granted to the file, and what is the replication factor for a file. All this information can be obtained by using file status class. Okay, so if you want to know whatever is the data you obtain by using this file status, whether it is equal to the existing metadata or not, that you can match by using assert that function. Assert that will return true and passes on to the passes the control to the next statement once both the parameters passed to it matches. If it doesn't match, then it raises exception. Okay, that is what we understood to use file status class. Now in today's class, we are going to see how to list the files and how to use path filter in order to filter out some paths which we are not interested in. And finally, how to delete the data from a file. Okay, these are all the concepts we covered. We have used 2 classes. We have defined 2 classes. One to show the files, show the file status, and one to show the directory status. Okay, file status for file and file status for directory. 2 classes we have defined in order to get the metadata about a file and about a directory. Now let us start with the concept of listing the files. Now finding information on a single file or directory is useful, but you also often need to be able to list the contents of a directory. So if you want to list all the contents of a directory, if you want to know the structural hierarchy under a directory, you can do that by listing the files. For that, what method do you use? File system classes list status method. You use file system classes list status method in order to list the files. Now there are different overloaded versions of this list status method. So let us see what are the parameters that help us to overload this list status method. What are various versions of this list status method that are available? Now whatever is the version or whatever is the overloaded form of this list status method, you observe this return type. It returns array of file status. Understand this carefully. It is not returning a single file status. It is returning array of file status. What do you mean by this? If you want to know the file status of multiple files, if you want to know the metadata about multiple files, that can be obtained by using this file status array, right? When you're taking the metadata of a single file, when you're obtaining the metadata of a single file, you can do that by simply using file status. But if you want to obtain metadata of array of files, multiple files, still you can do that by getting file status array of file statuses that you can obtain for list of files, right? So how do you do this? We use the list status method, and what is the first overloaded version of this list status method? You can pass a file path. If you want to pass a file path, means a single file's description, a single file's metadata if you want to know, a single file status if you want to know, that file's path can be passed as parameter to this list status. This is same as getting the metadata about a single file. Now the second version has two parameters, the path to the file whose metadata has to be known, and also the path filter. This path filter will help us to give a regular expression according to which some files can be deleted and only some files can be listed. Say under a directory you have some 10 files. Out of those 10 files you are interested to know only metadata about 6 files. And the other 4 files metadata you are not at all interested to view. In such cases, you can provide a regular expression to filter out those 4 files data and get only the 6 files metadata you are interested in. Right? For that, you can use the path filter. I'll show you how exactly we can use that. Right? And the next version is list the status of multiple file paths. Okay, so observe this here. In the first version you are using a single file path, but in the third version you are using multiple file paths. You are using array of file paths, means all the file paths mentioned in the array. Say path 1, path 0 will have the first file path, say dir file 1, and in path 2, path 1 you have dir file 2, and in path 2 dir file 3 under directory file 3. You can specify array of such paths in order to get the metadata of all those files at a time. That is the advantage of this list status method of file status of file system class. Okay, you can obtain the metadata of multiple files at a time. For that you are using path array. Instead of single file path, you are using array of file paths to retrieve the metadata of those files. And the last version for this is list the status for array of file paths at the same time passing the filter. Why do you use this filter? To filter out the file paths that you are not interested in to know about their metadata, right? All such versions of list status method can be used in order to get the information, in order to get the metadata about those files. Now, how to define a Java code for this? How to implement in order to work with listing of files? Let us write a simple Java class to perform this task of listing the files. Okay, so what you're doing for this program is to show the file statuses for a collection of paths in a Hadoop file system, not a single file's data, but you're trying to get the file statuses, you're trying to get the metadata about multiple files. Okay, for that you're writing this Java code now. How you do that? You define a public class, list the status, and in that you start with main function. And what parameter do you pass here? Whatever file path you pass as command line argument, that is taken as the URI for which you have to create a file system path. Understood? You have to create a file system object, means you have to create a connection to the file system that is passed as parameter, as command line argument. Okay, for that you are creating a command line argument, for that you are creating a string variable which takes that command line argument from the run window. Now you also create a configuration object. You very well know that whenever you are trying to work with a client or a server, this configuration object encapsulates the configuration of that client or server. That is why when you are working with systems on a cluster, you have to use this configuration object. Then you're creating a file system object which creates a path to the URI mentioned and associates that with this file system object. You're creating, using URI class, you're creating an instance of this URI, what is mentioned in the command line argument, get that instance associated with the file system object. Now you have established a connection with the file on the file system of Hadoop, right? You're trying to establish a connection through a representative of that file on the file system in Hadoop. Got it, students? Now you have to define the array of paths by taking path array as new instance of the argument string length. Say if you pass 3 files in order to get their statuses, or if you pass 10 files in order to get the metadata of those files, that will be passed as command line argument itself, right? Means those are obtained in this argument string vector as command line arguments. Now that argument string length is taken. Why you want the length? You wanted to know how many files metadata the user is interested in. So he will pass those many files as parameters. Now that parameters length is found, that array of parameters length is found, and that much array of paths are created. Understand this carefully. When you want to know the metadata about list of files, now all that list of files will be passed as parameter when you are executing this class, when you are running this class list status. What is my class name here? List status. Now I pass dir file1, again dir file2, again dir file3. So how many command line arguments I have passed here? 3 command line arguments. So in argument string vector 0, I'll get this file1 path. Argument string vectors 1, I'll get the path of file2, and args 2, I'll get the path to file3. Now what is the length of this argument string vector? 3. Now 3 such path objects have to be created. So your path array 0 has file1 path, path 1 has file2 path, and path with subscript 2 has file3 path. Did you understand now? This argument string vector is read from the command line argument, and to be sufficient for those command line arguments, you are creating a path array to accommodate those file paths. Now you have 3 paths available. You are interested in fetching the metadata about these 3 files that are stored in the paths that are provided, that absolute path that is provided with this path array, right? So that paths are taken, the argument string length is calculated, and those many paths are also created. Now see the for loop, what it does. You are referring to each path now. Why you have to refer to each path? Why can't you get all the file details at a time? It is not possible. You have to refer to each file with respect to path 0, with respect to path 1. Means in the array, you are referring to the 0th file, you are referring to the first file, you are referring to the second file, in order to get the metadata about those files separately, right? So you are taking a for loop to access those paths separately. You are using for int I equal to 0, for I less than paths dot length. What is there in the paths array? say this is paths array. What is there in the paths array? The file paths that you want to retrieve the metadata about. Okay, so that file paths, till those file paths dot length means how many files are there here. Paths dot length will give you 3. Okay, so I equal to 0 refers to the first file, I equal to 1 refers to the second file, I equal to 2 refers to the third file, right? So these, for each of these paths, you're creating a new instance and storing that in the paths array. Okay, so you're creating a new instance of this command line argument, argument 0, and storing it in the path 0. For file 1, you're creating a new instance and storing it in paths 1 space. And file 3, you're creating a new instance and storing it in paths 2. Paths array second location. Got it? So you are now available, you are now facilitating the access to these files through the paths. Got it? What you're doing overall is you're getting the file paths through the command line argument and storing those in the paths array. Now using those paths, you're getting their metadata, you're getting their file status. I'm repeating again, listen carefully all of you. You are passing the list of files as command line argument. They are first read into the argument string vector. Now from that argument string vector, you are reading each of the file paths and storing them in the paths array. Now you have all the paths available for which the metadata have to be fetched, for which the file status have to be fetched, right? That is why you retrieve the paths separately. Now take the file status array. If you are working with a single file, how should be this line? If you're working with a single file, this subscript, this will not be there. If you're working with a single file, you work with a single file status. You're fetching a single file status. In such cases, you need not have array of statuses. Okay? So when you are working with single file, this subscript will not be there. You just have file status, object status. But now you're trying to fetch status of 3 files here. So you're using array of file statuses. So file status, use the subscript, you give the status object. Now how many objects are created? You know how to create array of objects, right? So when you use file status, array of objects, status, how is the array allocated? You have status 0, into which all the first file's metadata is retrieved. Then you have status 1, into which all the second file's metadata is retrieved. Then you have status 2, into which all the third file's metadata is retrieved. Very easy to understand, right? If you lose anywhere continuity in the middle, stop me, I'll explain you once again, but do not sit with a doubt in the class. Okay, so here you are creating the file status array and you are listing out all the paths. See the usage of list status method here. You are using the file systems. Observe this, what I'm circling here. FS file systems method list status is being used here by passing all the paths as parameters, right? Now you are creating a path array once again for the listed paths and you are taking the file utility stat to paths to get the status. Okay, you are using a file system, you are using a class called file utilities from which you use the method stat to paths. So what does that indicate? You are converting stat to the path format and getting the statuses of those files and storing that data in listed paths. Now listed paths 0 location listed paths 0 location contains file1 status. Listed paths 1 location contains file2 status. Listed paths 2 location contains file3's metadata. Got it? So you have to access those statuses separately. How can you do that? By using a for each loop. You know how to use for each loop, right? For every path P, in the listed paths, which will have different file status, print it on the screen. System out println, print each of those details that are retrieved into listed paths, which will print all the file statuses for the collection of paths in this listed paths array. Got it? Now see this, you may understand even better. We can use this program to find the union of directory listings for a collection of paths. So how do you run this class? By using Hadoop command, using the class that you want to run, and this is the list of files from which you want to know the statuses. These are the list of files for which you are interested to know the file status. These are the files for which you want to know the metadata. Okay, so how many files you're passing here? 4 files. You're interested in knowing metadata of these 4 files at a time. That is why you're using the list status method of file system class. If you want to list the status of a single file, you can do that with status method. But if you want to get the metadata about multiple files, you have to use this list status method of file system class. Got it? Now how to use a path filter. Students, just raise your doubts if you have any. Till here? Did you understand the code very well? Can I proceed further? Students, are you there? Listening to the class?
Yes, ma'am.
Yes. Do you have any doubts till here?
No, ma'am.
Okay, then now let us learn about path filter. Path filter is the equivalent of Java IO file filter for path objects rather than file objects. When you're working with files on local machines, you can use file objects. But when you're working with files on file system on Hadoop, then you have to use the path objects instead of file objects. And this path filter is works the same as Java IO file filter. Okay, now let us write a path filter for excluding paths that match a regular expression. So if you want to get all the files in a directory except few files, now if you want to filter out those few files, you're not interested to know about the metadata of those few files, that you can match with a regular expression, so that if a regular expression matches with that file, say format, in such cases, those files can be filtered out, and only some files which you are interested in can be, for those files, the metadata can be retrieved. So how you do that? Create a public class, define a public class, regular expression. See this is regular expression, exclude path filter. Just again, it is indicating the purpose of this class. Remember, in Java, you can't name the classes as public class Kavya or public class Murli. You can't give a name that doesn't suggest what is happening in the Java class. You have to give the names very appealing. They should be obvious. They should be self-explanatory, which explains what is the purpose of that class you are defining. Okay, so here you are defining a class, regular expression exclude path filter. Okay, implements which interface? Path filter interface. Now create a private final variable. Private final variable means it can't be changed further, and it can be accessed only within this Java class, right? regular expression, you are making it as a constant one and you're making it private to this Java class itself, right? Because you want to keep it static. You don't want to change the regular expression. Often, in such cases, you can make it as final. But if you tend to change the regular expression, you can remove final and simply you can print, you can take private string regular expression. That is also fine. Okay, now you give a constructor here, public. This is a constructor which takes by default regular expression as the parameter, and that regular expression is initialized. This regular expression, the private variable of this regular expression, the private variable regular expression is initialized using a constructor, right? Now you take public boolean accept, one more method which accepts the path and returns a boolean value. See the return type here. This method accepts a path and it returns a boolean value. What is that boolean value? When does it return true? When does it return false? Returns when not path converted to string matches the regular expression. Whenever this regular expression doesn't match with the path, then it returns true. Otherwise, it returns false. Understand this carefully. This accept method accepts a path, accepts a file path, and when this file path doesn't match the regular expression, it returns true. And such files metadata is retrieved. When it matches with the regular expression, you want to filter out such files. You don't want the metadata about such files. In such cases, it returns false. When there is a match with the path, when there is a match between the path that is passed and the regular expression, that file is filtered out. It returns false. But when there is no match between the path that is passed and the regular expression, it returns true. Then that file will be considered in order to get the metadata, in order to get that file's status. Okay, that is how we use PathFilter. PathFilter has a method accept which lets us customize the method according to the filter we require. Okay. Now the filter passes only those files that doesn't match the regular expression. Once it matches the regular expression, once the file path matches the regular expression, then it will delete that file. Means it will not consider that file, not deleting. It will not consider that file to get the metadata. Only for which the file and the file path and the regular expression matches, for those files the metadata is retrieved. For those files the file status is retrieved. Okay, the filter passes only those files that don't match the regular expression. Got it, students? That is how we can use the regular expression in a path filter. Now, after the glob picks out an initial set of files to include, the filter is used to refine the results. Glob is like a pattern matcher. Okay, this glob helps us to match the patterns. So after the glob picks out an initial set of files to include, the filter is used to refine the results. So in this case, you can take this example, file system, glob status, the new path that you are passing here, and it is trying to match that with the regular expression exclude filter. And this will expand to 30th December 2007. Means what you're trying to do with this glob status here is, if you want to get the files that are modified until 30th, okay, such kind of files can be retrieved. And beyond 31st, if any files are modified, you are not interested to get the metadata of those files. That is the example given here. That is the importance of the regular expressions that will help us to filter out some files and let us consider only some files that we are interested in to know about the status of those files. Now, filters can act only on a file's name as represented by a path. They can't use a file's properties such as creation time as the basis of the filter. Understand this point carefully. Whenever you're giving regular expression on a modification time, still this filtering happens only on the original files, not based on the creation time or modification time. Though you're giving the condition on modification time, the original filtering happens with the file itself, not according to the modified date. Right? Now I'll read this point once again. Filters can act only on a file's name as represented by a path. They can't use a file's properties such as creation time as the basis of the filter. Only the file names act as filter. Though you give the condition on modification time, or though you give the condition on some other parameters. Now, how to delete the data from a file? Use the delete method on file system to permanently remove files or directories. Say you wanted to delete a file, or you wanted to delete data from a file, or you wanted to delete an entire directory or a subdirectory. How can you do that? By using the delete method. And what value it returns? It returns a Boolean value. If the file is successfully deleted, it returns true. If the file can't be deleted because of some dependencies, then it gives false. Okay, what parameters it accepts? It accepts path, the file path as one parameter, which file needs to be deleted. That can be passed as parameter. And another parameter is recursive. I'll explain you in a short while what this recursive actually means. And this throws IO exception because you're trying to find out a file, locate a file and delete the data from the file. Still, it may throw some exceptions which can be handled by the system gracefully by using throws IO exception. Though these topics are very simple for you to understand, I'm repeating it again and again so that you will not forget it forever. Okay. Now, if F is a file or an empty directory, the value of recursive is ignored. Understand this. Now, why we use this recursive? If whatever is the recursive value, whether it is true or false, when you are trying to delete a file or an empty directory, if F is a file or an empty directory, then the value of recursive is ignored because empty directory can be deleted and file also, single file also can be easily deleted. In such cases, recursive's value is not considered at all. It is ignored. But a non-empty directory is being deleted. If at all a non-empty directory is being deleted, means the directory has much hierarchy of subdirectories and files under it. And such non-empty directory is being deleted along with its entire contents. Then recursive has to be made as true. Means when a directory has some underlying content, when a directory has some good amount of hierarchy of subdirectories and files, in such cases, still forcibly if you want to delete the directory, then you have to set recursive as true. Only then this non-empty directory will be deleted. This is a care that is being taken. Whenever some non-empty directory is being deleted by mistake, in such cases, it will raise some error if the recursive is made as false. Now, if you make the recursive as true, then it will forcibly delete all non-empty directories also, indicating it treats that you mean to delete that directory. You wanted to forcibly delete that directory. In such cases, if you want a non-empty directory to be deleted forcibly, you can set recursive to true. But once it is set to false, it will raise an exception. It will raise an exception that a non-empty directory is being deleted. I'm repeating again, if recursive is set to false, it will raise an exception indicating that a non-empty directory is being deleted. But if the recursive parameter is set to true, then you want it forcibly to delete the non-empty directory. It will not raise any alerts. It will not raise any exceptions that a non-empty directory is being deleted. It reads that you are interested to delete a non-empty directory and it deletes accordingly if you give this recursive as true. Got it? In the next coming session, we are going to understand about anatomy of a file read and anatomy of a file read. Most important topics of this chapter. And you will get a compulsory question from any of these two operations. You are trying to understand how a file read happens in the background on a HDFS cluster. Very interesting also. One diagram if you draw, you will be able to explain based on the diagram itself. If you know the diagram in and out of the diagram very well, if you know what each component does in that file read operation, if you know very well what functionality is associated with every component in this anatomy of a file read or write, then you can automatically answer this question very easily. Okay, so do not miss this class in which I explain anatomy of a file read and anatomy of a file write. Any doubts, students? Till here? If you're not answering anything, I would assume that you have understood everything. Even in the class, I notice students are paying interest, they're listening, but their presentation in the exams is not as good as that. I can see your faces and assume that you're understanding very well. But in exam, I can't see that level of presentation. So refer to the classes again and again. At least the first 3 chapters are very easy to understand. From the 4th chapter, you have to pay little more effort and understand all the Java code, because you have to write the code, no other way. If you are asked to write Java code for reading data from Hadoop URL or reading data from Hadoop file system, you have to write answer it, right? For that, you can't by heart the code. You should understand each and every line of the code. So refer to the videos repeatedly until you understand, or you can WhatsApp me your doubts. I'll try to clarify them. Okay, I'll stop the recording. Meet you in the next class.